morning, Geometry iPad Initiative students. This is Mr. Lane coming at you again from OHS High School. Today we'll be talking about section 5.8, which is applying special right triangles. Yes, I did say special right triangles. So make sure you read the objective, make sure you read the why, and the number 5, make sure it gets answered in your notes for full 5-point credit. So make sure you pay attention to the secret word today. It's actually a phrase, and it's going to be worth 3 points. Yes, I said it. 3 points. That is exactly right. So let's get going on this. The first theorem that we're going to talk about is the 45-45 90-degree right triangle. Yes, it's talking about the two 45-degree angles in a right triangle, which obviously if it's a right triangle, then it's a 90-degree angle for the other one. It's a real simple, real straightforward theorem for you. All you have to do, once you recognize that it's a 45-45 90, is if you can find a side length, you multiply it by the square root of 2 and you get the hypotenuse. Now, why is this important? Well, it gives us a very easy shortcut instead of having to use the Pythagorean theorem to figure out what the hypotenuse would be. So it saves us a ton of time. Also, if we look at the theorem, if we've got the hypotenuse is equal to the leg times the square root of 2, well, we can find out what the leg is just by dividing both sides by the square root of 2, and we could figure out what one of the legs would be that way. So we'll have some examples here coming up on the next page. Looks like our first example, we're supposed to find the missing side lengths. So I'm going to find this side, and I'm also going to find that side. But first let's talk about the angles. I got a 90 degree. I could add the 45 degree to it, get the 135, subtract it from 180 and get the 45. Of course, if you know that you have a 90 degree and one angle is 45, might as well just get used to the other one being 45 also. Well, the angles across from the 45 degrees are going to be the exact same length. So if this is 8, then this missing side length over here would also be 8. And then what we just learned from the theorem, and I copied and pasted it onto this page, is that if we take one of the legs and we multiply it by radical 2, then we got the hypotenuse. So all this would be is 8 radical 2, and we'll leave our answer in simplest radical form, which we've discussed already, and we're done with that example. Alright, this example, notice that we're given both legs. If these two legs are congruent, then that's going to be a 45-45 degree right triangle. So all we do to go from a leg to the hypotenuse is multiply it by the square root of 2. So I'm going to take 3 radical 2. I'm going to times that by radical 2 to equal my hypotenuse. So let's see, that would be 3 radical 4. Well, radical 4 is just 2, so 2 times 3, bam, 6, and we're done. So the hypotenuse would be a length of 6. So real nice, short, easy problems here. Let's keep on rolling. Alright, now on this one, notice that again we're going to have a 45-45 90-degree triangle. But this time we're given the hypotenuse. So if I have the hypotenuse is 5 radical 2, and I know that that's equal to a leg times radical 2, all I have to do to get rid of the radical 2 is divide by it. So if I divide by radical 2, notice that the radical 2's disappear, so one of my legs would have to equal 5. By the way, you're doing the secret word a little bit early in this video, or the secret phrase I might say, which is brownie sundae. Yes, both words, 3 points. First person to send them to me wins. Alright, here's the problems for the regular geometry class. iPad Initiative students, as always, yours is up and ready to go on the Lumen Touch website. Alright, next theorem, very important here, is a 30-60-90 right triangle. So again, we're going to have one right angle, we're going to have a 30-degree angle, and a 60-degree angle. Now you can read through this, but basically here's the way it works. My shortest side length, I'm going to call that X. We might be giving it as 5, we might be giving it as 10, but we're going to call it X for right now. Well, to get the side opposite of the 60-degree angle, all I have to do is multiply that by radical 3. Well, to get the hypotenuse, all I have to do is take the shortest side, which is always across from the 30-degree angle, and multiply it times 2, or double it. And that's all there is to the 30, 60, 90. So instead of using Pythagorean again and long drawn out problems, taking the square root of things, all I have to do is apply these short little theorems. Alright, let's see here. Alright, it looks like we got an example here. We got a tablecloth with a diagonal, so I'm just going to draw a little quick square here. And let's see, across the diagonal of the table is 36 inches. And she wants the diagonal of the tablecloth to be an extra 10 inches, so that's going to make it what, 46 inches? So it will hang over the edges of the table. What size square should she cut to make the tablecloth? Well, so we got a diagonal of 46 inches. Well, if I'm talking about a square, then I've got a 90-degree angle, and it's going to be one of those 45-degree angles again, because cutting through the diagonal is going to cut that 90-degree in half, so it should be a 45, 90-degree. So if the hypotenuse is 46, to get back to the leg, remember I have to take the hypotenuse and divide it by a radical 2. So all I'm going to do is simplify this to simplest radical form. So I'm going to multiply it times radical 2 over radical 2 is going to give me 46 radical 2 over 2. Cancel the 2 at the 46, and that's going to leave me with 23 radical 2 inches. I could punch out a calculator and round it to the nearest inch if I had a calculator to use. So let's see, regular geometry students, we'll be doing 4 and 12 from 360 at this time, where we're going to cruise on right now. Alright, we got to find the missing side links. Looks like it's labeled X and Y here. So it looks like X is across from the 30. The only link that I'm given is across from the 60. Well, how is that related to X? Well, I know if I had X and multiply it times radical 3, that would give me 9. So I'm just going to fill it into the equation here. So 9 is equal to X times radical 3. So I need to divide by radical 3 to figure out what X would be. Alright, so let's see. X then would equal, well, to simplify this, I need to multiply by radical 3 over radical 3. So I'd have 9 radical 3 over 3. So I want to cancel the 3 with the 9, and it will leave me a 3 radical 3 for X. Bada boom, bada bang. We figured out what X was. Bam, bam. Alright, now we got to figure out what the hypotenuse is, but that's pretty easy once we have what X is, because all we have to do is take the shortest leg and multiply it times 2 to equal the hypotenuse. This first little equation right there for us. So let's see, if I want to multiply 2 times 3, that's going to be 6. So 6 radical 3 would give me what Y is. So bam, we're done with that. Let's go on to the next problem. Here again, we're trying to find the missing side links. I'm going to call the hypotenuse Y again. It's not labeled on this one, so we're going to find X, then we're going to find Y. This time across from the 30 is radical 3. So remember, from the shortest leg to the longer leg, all I have to do is multiply the shorter leg times radical 3. So I'll have 3 times radical 3, which would be radical 9, or just 3 for X, or the longer leg. Now, to get to the hypotenuse, I take the shorter leg, which is radical 3, and I double it, or I multiply it by 2. So what's 2 radical 3's? Well, it's just 2 radical 3. And we're done with that example also. A real nice, short and easy. Makes some real easy problems to work. So regular geometry class would be doing 6, 14, and 15. And we're almost wrapped up with this. So an ornament pin is in the shape of an equilateral triangle. Equilateral means all the sides are the same. The length of each side is 6 centimeters. So I'm going to label that 6 centimeters. Josh will attach a fastener to the back along segment AB. So I'm going to call this AB. I guess that's our fastener. Will the fastener fit if it is 4 centimeters or long? Alright, well, if this is the altitude that we're dropping the fastener down from, equilateral is also going to be equiangular, so this would be a 60 degree for the entire thing, and this is going to be cut in half. So that's going to be a 30 degree, that's going to be a 90 degree, and that's going to make this a 60 degree angle here. So across from the 30 we do not know, but we know across from the 60 is, actually let's go this route. If the hypotenuse is 6 and that's doubled from across from the 30, then across from the 30 would have to be 3. So for the fastener to fit, we'd have to take 3, radical 3, and punch that out on our calculator. So let me pull up the old calculator, I guess. Accessories, calculator, boom. And we're going to take 3 times the square root, oops. Actually, we're going to hit the square root there, and let's take that times 3. Let's clear that. 3 the square root times 3 equals, looks like 5.1. So the fastener is not going to fit because it would have to be a length of 5.1 centimeters to stretch from the upper vertex down and be the altitude of that. So that fastener would not work. Alright, regular geometry students would be doing 8 and 12. Then it would be time for the up one, down ones. Then it would be box time. Good luck here. Yeehaw! Man, the boxes aren't working. Alright, let's move on. Okay, this is Mr. Lane signing off from OHS High School. Have a good day.